Good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Why Did My Build Fail? Using AI to Troubleshoot Faster with Failure Summaries is my fantastic colleague, Laurent Ploix. Laurent is a senior product manager at Gradle who joined us just over a year ago from Spotify, where he had spent 10 years as a product manager for their continuous integration team and also led their platform insights team. In today's presentation, which will be shorter in length than some of our other webinars, we take a look at some of the challenges that come with making updates to large projects on CI. You probably know the drill. A simple change creates a cascade of hundreds of different builds, resulting in the proportionate amount of failures and flaky tests. And what do you do then? Well, look at massive log files and 6 different UIs, right? Well, hopefully not for much longer, as Laurent will demonstrate for us today. Failure Summaries is a brand new Develocity feature that uses AI to cluster and categorize tests to determine which of them are related to specific build failures. For example, if one root cause causes 10 tests to fail in one build, we know now how to fix all of those failures at once, rather than looking into each failure individually and tracking down a specific test manually. So while we wait for everyone to get settled with their coffee, tea, fizzy beverages, and so on, we've got a couple housekeeping items to go over. Today's session, since I'm always asked, is being recorded and it will be shared with you next week. Lastly, this webinar and all of our DPE events are made possible only by the support from our hundreds of happy customers, including Netflix, who is currently looking for a senior software engineer to work on their developer automation platform in Los Gatos, California, as well as an engineering manager for developer enablement in Poland. If these sound interesting, you can ping me in the Zoom chat for the links or just search for those positions at Netflix to find out more. All right, that's all from me. Let's hand it over to Laurent. Thanks for joining us today, Laurent.
Thank you, Oliver, for the introduction. When I worked as a developer, I felt that I spent most of my time troubleshooting issues. Writing code was fun, designing was fun, but parsing log files was not. I spent a lot of time reading stack traces and tried to understand the root causes. Sometimes, one small change would create a lot of regressions, and I had to figure out what the real problems were. Today, we're looking into it. So, we're going to look into the developer workflow, how we modelize it, maybe look into a metric as to how to measure its efficiency, and what does it take to reduce complexity. Then, I'm going to show you what we have internally at Gradle, what we dog food, but also what we delivered in 25.1 in beta. So first, let's talk about the developer workflow, the simplification thereof. As a developer, I need to fix a bug or implement a new feature. So I'm making a step in the right direction. I'm making a change or several changes at once. And then, of course, I build, I test, either locally or in CI in my pull request. And most often, unfortunately, I will get some kind of failure. And that's the time when I need to troubleshoot the problem. What we see is that, of course, in large code bases, and especially if I touch some lower level code, I might actually trigger a lot of failures. There can be many of them. It can be quite hard to parse. And with the coming of AI and all the help we get to write code, what we see is that modifying code or changing code actually leads to bigger changes, more code gets created. The build and tests become applied to larger code bases, and we see more tests being run. The troubleshooting operation actually is a lot more difficult. In my experience, troubleshooting is roughly 70% of the time. That's a lot. We need to simplify that. But first, how do we measure that? Let's look into a metric that makes a lot of sense. So I'm a developer again. I just took the code from the main branch and then I run it. It works. And I make a small change and then I get into a red build. Something fails. Either it doesn't compile or some test fails. And it's going to take me a few iterations before I get back to green. This is time to recovery. We usually use time to recovery to talk about incidents, but seriously, it also works for local builds or for pull request builds. In this case, you make one step in the right direction, gets back to green, and then you iterate, and you do it again. And you got another TTR aspect. One may have taken 5 minutes, the other one 10, or maybe a couple of hours. In fact, if we look at what this metric looks like, the distribution thereof, it looks like this. What can we say about it? You cannot fix problems faster than you can build your code. So this is a bare minimum. And then you got a number of cases where it's quite simple to fix a problem. Maybe you made a typo or something pretty obvious. On the left, here in the clear problems, they are very simple problems to fix. And then you got the complicated ones. You must reason about how the code reacts. There is a model you have in your head. You can reason about it. And then you're going to have the complex issues. Some takes, so clear problem takes minutes, complicated ones up to an hour or two. And then it can take a long time to fix the complex issues, not to mention the chaotic aspects. But we want to reduce this complexity, right? You might recognize the Kinevin framework. The point of this one is the following. Clear problems are, obviously I know what to do. I understand the problem. I see immediately what I can do. The complicated ones are, you need to analyze cause and effects. You have a model in your head of how the things work. You're going to try things and you're going to find a solution relatively quickly. The complex ones are, I don't quite understand. I need to build this model in my head. I need to go deeper into the code. And the chaotic ones are, it makes no sense until I look deep into it. What we really want to do is turn complicated problems into clear ones, complex ones into complicated, chaotic ones into complex. We want to simplify the world. And in order to do that, we will need to give a clear explanation to developers as to what the problems really are. So we want to change how the metric looks this way. We want to make faster builds, thanks to predictive test selection, test distribution, caching, parallel builds, everything that Develocity provides. But we also want to simplify the analysis of the issues, the troubleshooting problems, and we want the curve to look like this, moving it to the left. But how? How do we do that? First, we need to understand where the complexity comes from. Complexity for a developer comes from unclear failure messages, very long log files. I have seen log files up to 20 megabytes long. Makes no sense for a human being. I've seen stack traces with many levels. Nobody wants to see the exceptions that appear deep into some library. Or you can have a lot of failures coming from one build, and you need to understand which of the root causes there are. And of course, flaky tests and infrastructure issues. So now I'm going to show you what we have internally at Gradle. At Gradle, we dogfood everything that we do. We obviously use Develocity to code, develop, and we can experiment on ourselves with ML failure summaries. So what does it look like? The failure summaries apply, we have built a bot, basically that apply to our continuous integration. So what does it do? We take GitHub pull request, and when a pull request is submitted, of course, that generates continuous integration, which itself is going to generate a lot of builds. There would be multiple platforms, different ways of running Develocity, and of course, that generates a lot of different cases. The same tests are going to be run in different setups. If a similar problem appears on all platforms, we only want to see it once. If many tests fail to the same root cause, we also only want to see it once. But if similar tasks fail, we want to group them. How do we do that? So we collect all the build scans. Build scans, as you know, contain a lot of information about everything that happened during a build. And then we generate a summary thanks to machine learning clustering. And I'm going to show you what it looks like. So first, you can see here, that's actually a bot in GitHub that produces this failure summary. It will cluster problems, and I'm going to show you how. It takes, as I mentioned, all the build scans from the pull request, looks into all the problems there were in all the builds, and cluster the issues. And it looks like that. In this case, we have 14 failures, but really, we have three groups. One group of 11, one group of 2, and one single test, which is isolated. Sometimes it's not 14 you get, it's 100 or hundreds of failures. But maybe you got only one root cause, or 2, but certainly not 100. Most often, fixing one of the problem out of the 11 will fix all the other ones. So we only want to show you 3 things, not 14. Those issues I like to mention are not exactly the same. They are semantically the same. So it's not about checking for equality between all the failures. No, it's a clustering aspect. They are semantically the same problems. And of course, not only do we create the groups, but we isolate the root cause or the most probable root cause. In this case, we see we have two root causes. One group with access denied exception, which is the most relevant exception, and the second one with some condition that is not satisfied. Potentially, you can have very long stack traces. The key here is to extract the one that makes the most sense so that you understand what's going on. In this case here, we realize that it's a task failure. We realize that it's an infrastructure issue. The problem is actually quite deep in a log file. It would have taken you dozens of minutes to find it, and it can be really, really hard to spot. But we extract the information from the log file, and we will see that in another case a little bit later in the presentation. Here we can see, hey, you really have a problem with a database connection. You might want to talk with someone who is in charge of this database. Or maybe you have a problem starting the database during the running of the test. It shows you, hey, it's actually not a testing problem. It's something else. So basically infrastructure. So with that, we see that first we group the failures, which are semantically the same. We isolate or we explain in one clear sentence what the problem is. And we show you is that an infrastructure problem or not. This is what we have internally at Gradle. We iterate on that. We work on it. And some of it makes its way into the product already in 25.1. And this is what we're going to show you now. So the failure summaries are now available at the build scan level. What is really interesting about build scan is that they come both from local builds on your own machine or in CI. So you will benefit from these features even for the builds that you run locally on your own machine. And that's kind of similar to what I showed you before. Here's a build scan where you have two failures, but in fact you have one group. So they are similar. And the build scan will show you, hey, you have one group. And again, if you had 15, maybe it would have shown you one group of 7, one group of 8. Again, similarity doesn't mean exactly the same. It means it's semantically close. And of course, it will also show you if you run a build and you have, like in this case, a Git problem. What is interesting about this case is that those two lines, the fact that the Git executable return a non-zero exit code and the fact that it's permission denied are very far apart in the log files. But we extract the part of the log file that makes the most sense, and we put them together to show you what the actual problem really is. So just by looking at this summary, you identify exactly the root cause, and now you can fix the key, apparently. So again, we sort of connect the dots between different parts, and we make sense of it in a summary that is easy to read, easy to parse, and easy to identify what the root cause of the problem is. In the case of code quality tools or linting, we can extract, again, the rule violation, which can be far apart from the error message. And we show you exactly what the problem is, the rule violation, for this linting process. It would have taken a lot of time to look into the long log file to find the same problem. So to summarize, we cluster similar failures, show you only the root causes that make sense. So if you have 20 failures, you might have 2 root causes only. We show you the most relevant message from log files, and we can separate the concerns between infrastructure issues and test failures. That is available in 25.1 in beta, and you can contact us if you want to turn it on. What's next? Well, Develocity is a treasure trove where there's a lot of information about the builds, and we can create a lot of value from it. For instance, we can contextualize the failures. What other people have the same problem as I have right now? It works on my machine, the code runs on my machine, but it doesn't work in CI. What's happening? What are the differences? Maybe it can tell me who to talk to. Maybe someone else is having the similar problem and fixed it. Or maybe I should talk to the infrastructure team. And maybe longer term, we could even suggest a fix by looking at how other people fix similar issues. With that, I would like to thank you for listening, and
Laurent, is there one more slide after this one?
There is. Thank
There
you.
is.
Here you go.
All right. So before we get to some questions, I just wanted to let folks know that we have recently revamped our trial program. So if your organization is not yet a Develocity customer, we'd like to invite you to request a trial of Develocity. The way it works is over a few weeks, you and your team will work hand in hand with our engineers to securely set up Develocity in your own environment so you can start using features like build and test acceleration, predictive test selection, which also uses AI, as Laurent mentioned, flaky test detection, failure analytics, and more. And at the end, you'll be able to show your management team a proven ROI using your own project. So how much time did you save using build cache, for example, or predictive test selection, and so on. You can learn more about that at gradle.com/trial and tell them Oliver sent you. All right. Well, folks, if you had some questions that we weren't able to get to, you can email me at owhite@gradle.com and we'll see if we can get some answers for you. Laurent, thank you very much for the presentation today. I hope everybody enjoyed it, and we will see you next time.
Thank you.